So, welcome to our first chemistry virtual session. We are going to be going over energy and temperature, which is a lesson that is coming up for you guys. So we're going to do the notes, and then when we're done with today, you should be able to take the energy and temperature quiz as your exit slip.
And those of you who are in
Hi,
here,
Jamie.
break,
So, rules for virtual sessions. Cameras on, right? Participate. Be respectful. That's it. If you are very shy about being on camera.
Excellent question. So that is what it did for me, but then we realized that it did not take it off your calendar.
You can turn your camera on and you could just angle your computer down or up, right? I've seen people angling it pretty far up so that you're not on the camera, but we do want to make sure you're there, because last year I had some people attend my virtual sessions and they weren't actually attending. They just like came into the room and then left and then weren't there. So I just want to make sure you really exist. All right, so our warm-up question is something that should be a really easy review. You guys, this is probably what, like your fourth or fifth year of science, at least, like as a class. So what are the major steps to the scientific method? Something that should just be a review. You can speak, you can write in the chat, you can just think about it for a few seconds here, but we're going to spend about 45 seconds thinking about this. Okay, awesome. I already see a little bit, some stuff going on in the chat here, so we'll just wait a little bit longer. Oh no, I have a dog hair in my water. Conclusion. Okay, hey, we kind of have it all here. Purpose, hypothesis, a procedure, right? A conclusion. Yeah, right? So we're pretty familiar with the process here. You have some kind of question or concept that you're trying to explore. You make a hypothesis about it. You do some kind of experiment, and then you make a conclusion, right? Were you right? Were you wrong? Did something insane happen? Etc. So that should just be a quick little review. I just wanted to get you guys in that science mentality here. So what we're going to do today is we're going to define energy. We're going to compare and contrast potential and kinetic energy. And then we're going to identify the types of energy seen in some pictures. We're also going to be talking about temperature, which is actually a measure of energy, which I should probably include on this objectives. Because okay. So Cornell notes. We will be using Cornell notes this year. Type a 1 in the chat if you are familiar with Cornell notes, you at least know what they are. Type a 2 in the chat if you're like, I have no idea what that is. Okay, we got like 60% yes and 30% no right now. So what we're gonna do is I'm just gonna really briefly kind of explain with this template how they work. If you are really new to Cornell notes, then I would watch the video or look at this other PowerPoint that I have as well. So I just sent to you guys the Cornell Notes template, right? If you prefer to take notes on paper, that's totally fine. This is a digital version so that you could do it on the computer if that's how you take notes. But if you open up that document, you will see that there's a space for you to write your topic or your objective, your name, your essential question, and then there are two columns here. There's a questions column on the left and a notes column on the right. So when you're going through your own lessons in Canvas, you're gonna have to come up with these side questions, right? What I would do personally is write your notes first, Then go back and say, okay, what kind of question am I answering in these notes? I'm going to tell you these sub-questions today for the most part, or subtopics that you could easily make into a question. And then at the end of these notes, we're going to be summarizing. So what were these notes about? Now, the point of this is not to cause you a headache, right? The point is taking notes is actually super beneficial, right? Even though it may seem like a pain and you're like, well, I have Google, I don't need notes. If you're taking notes, one, you're going to be actively listening because you're like, oh, what should I be writing down? And two, you're going to have something to refer back to when you are taking a test or a quiz. And I'm going to be checking very, very strictly for plagiarism, right? So it's important that you have all of this stuff in your own words and that you're really thinking about it and what it means rather than copying and pasting from somewhere. So this is the template that I would like for you to use. If you do it on paper, that's fine. Like with a pencil or pen, you're just going to take a picture of it and submit that. You may be thinking, oh, submit. So once a module, I'm going to ask you to submit notes. So my Canvas will load a little faster here. Our first module is called Chemistry and You. When we get to the end of the module, which is not going to be for a while, you may notice there's a ton of stuff in this first one. Did I skip it? There we go. Oh, well, I already went into module 2. Just kidding, there's not that much stuff. Okay, so September 27th is going to be the first notes check. And how it's going to work is I'm going to tell you the day of which lesson I would like to see notes for. So I might say, I want to see notes for energy and temperature. I want to see notes for blah, 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 blah. You're going to have 25 hours to upload your notes. So if you're somebody who doesn't take notes, I'm still giving you a little grace period here where you can produce some notes. If your notes are on paper, then you have plenty of time to be able to take a picture and submit that. Or scan it, right? I know some people are really into scanning. That's fine. If they're digital and you already have them done, you should be able to easily turn this in 3 seconds. And if you don't have them, like I said, you have 25 hours to make them, right? So the point of this really is I'm going to try to pick really important topics that you should have notes on, right? And this is just going to be a way for me to check that you have notes without being like, show me every single note that you ever took, because that's a lot to look through for me, and also for you, if you took them on paper, that's a ton of pictures, and like it's a lot of extra stuff that we don't really need to be doing. So just know that that's going to be coming up at the end of the month. Okay, so if you are new to Cornell Notes and you're feeling really concerned about it, because it is a little overwhelming at first, there's a great video here that's made by Mr. Ling, and there's also a PowerPoint that I made for my Avid class that has a step-by-step guide for how to do the notes. So this PowerPoint is going to be posted at the end of the session. You're welcome to go back and look at the video, look at the PowerPoint. You can skim through a little bit if you just kind of want to see, make sure that you know what you're doing. If you just want to use the template and interpret it in your own way, that's also fine. So our essential question for today is, what is energy and how can we measure it? So what you're going to want to do in your Cornell Notes setup is, in essential question, you're going to be writing, what is energy and how can we measure it? For the topic or objective, you could put the objectives that I already listed, or you could just write energy and temperature. Personally, I would put a topic there just because objectives are more like, I would say they're more for teachers and administration. They are for you, right? But I know sometimes looking at all those objectives, you're just like, okay. Energy and temperature, you're going to be like, oh yeah, these notes are about energy and temperature. If you're doing it on paper, same situation, write your essential question, write your topic. So when we're taking the notes, our first slide here, okay, is, that's for biology, okay, is going to be, what is energy? So on the Cornell Notes, in the left side, where it says questions, you're going to want to write, what is energy? and you're going to want to define energy, work, and I would put examples. You don't have to put examples. So I'm going to give you about a minute to write this down. Okay, so I'm going to start talking. If you're still writing, continue. But really, the difficult thing here about the terms energy and work is that we use those words in a different way in our regular language versus the science, right? So when you're thinking about energy in your normal world, you're probably thinking about like, man, I feel tired, or I feel like I have a lot of energy today, right? You're not thinking about the ability to cause change or do work, right? Work is the same kind of thing. You're thinking work, oh, I have to do my homework, I have to go to work. No, work is literally a mathematical equation here. It's force times a distance. So you can imagine if you're pushing a box, right? If you're pushing a box across a distance, you're applying a force, you're moving it across the distance, you're doing work. Actually, it would be kind of funny. You could always be kind of like a little smart ass, as we can say, to your parents. If they're like, oh, are you doing your work? You could just move something and say, yeah, I'm doing work. Right here, I'm doing work. Because you technically are, right? So it's moving matter of some kind. So energy needs to be able to push or pull or move something across a distance. In this case, the ability to cause change. A lot of times we see energy translating between different forms. So examples could be filling up a tire, heating up your food in a microwave. Both of those examples are using energy. So types of energy, right? There's two major types. And now for your question, you might be writing here, what are the two types of energy? And in your notes section, you're going to be writing potential and kinetic. Now, I tried to make these definitions like super short and concrete so that you're not writing long definitions. If you look up the definition for potential and kinetic, it's going to be much longer. It's up to you. You're welcome to put more. But this is what they mean, right? Potential energy is stored energy, and kinetic is moving energy. And it kind of even makes sense a little bit with the names, because potential kind of sounds like something has the potential it might do something, right? In this case, it's energy that might happen. Kinetic is moving energy, so already moving and in motion. So a really good example of how to like describe and think about these two terms here is a roller coaster. Our potential energy is going to be when the roller coaster car is on top of the hill, right? At the top of the hill, it has the most potential to fall down the hill, right? Whereas kinetic energy is going to be while the roller coaster is moving, if that makes sense. Another example could be if you have a rubber band, right? When you pull the rubber band back, that is potential or stored energy, because you are storing energy in that rubber band. And if you let go and it flies, right, that would be the kinetic energy or the moving energy. So seems kind of like common sense. Some of these energy definitions are common sense in some ways. So another important part of the energy equation here is the law of conservation of energy. So I wrote it over here on the side in giant all caps letters, because yes, I'm yelling about it to you. All energy is conserved or transferred, right? Energy cannot be created or destroyed. Now, this is one of those things where people are like, but can't it be created? I don't know. Like, it seems like you should be able to create energy, right? You're not creating it, you're really just pulling it from a different source. And you can't destroy energy. So that means that the same amount of energy has always existed on Earth, right? We've just been able to sort of move it to different forms so that we can access it. So this picture here is showing some examples of those conversions. An automobile, right, is changing chemical energy into mechanical and heat. So you're taking the chemical energy of gasoline and you're using that to change into a mechanical energy, which is your car moving, and heat energy, right? If you've ever felt the hood of your car after you drove for a long time, it's really hot because a ton of heat is being produced, right? Trees changed energy from the sun into chemical energy. So they take sunlight, they go through photosynthesis, and they produce chemical energy in the form of sugar. I can't even see this other one because I have so many things open. There we go. Hammering a nail, right? You're taking mechanical energy and you're creating heat energy, and it says here deformation energy, which is a weird sounding energy. We can have thermonuclear reactions, which take nuclear energy and turn it into radiant and heat energy. So that would be sort of like the reactions happening in the sun, right? The sun is having reactions that are producing heat and radiation energy. Electricity, right? You're taking electrical energy and changing it into mechanical, or maybe you're taking electrical and turning it into heat or light or radiation. So basically any kind of energy you can think of, it came from somewhere else, which is really the point of the law of conservation of energy, right? You're not creating or destroying energy. So types of kinetic energy. So this is where it's kind of, I think, like common sense in a way, just trying to get what these words mean. But we have mechanical, electrical, radiant, sound, and thermal energy, right? Some of them are kind of obvious. Sound energy is the movement of sound waves. Radiant energy, that's electromagnetic rays. So if you've already, maybe you remember what those are from physical science, that's going to be your X-rays, your radio waves, your gamma rays, your light energy. Electrical energy is the movement of electrical charges. So that's, or electrons really is what it is. So that's going to be in your outlets. And then mechanical energy is just moving from one place to another. So that could be physically, that could be a car moving, something turning. So mechanical, I like to think of like machines. So the last one, thermal, right, is heat energy. So you might even think like you wear like thermal underwear or thermal shirts when it's really cold out to conserve heat, right? So these words are kind of like common sense words, but just make sure you're kind of familiar with what type of energy that is. And all of these are examples of kinetic energy because they're all moving. Potential energy. If I went too fast there, don't worry, because this is going to get posted, so you can always go back and fill in anything that you missed. But the types of potential energy, right, we have stored mechanical energy. So this would be like if you have a spring and you compress it, if you let go, right, the spring's going to fly. So sometimes sometimes machines have springs or strings or other ways where they store energy. Chemical energy is stored in the bonds of compounds, right? So any food that you're eating has chemical energy in it. Plants are making chemical energy. Nuclear energy is stored in the nucleus of an atom, right? So there's a ton of energy inside the nucleus of an atom, and scientists actually use that to create nuclear bombs. And then we have gravitational energy, which is a positional energy. All it means is that the higher up that you hold something, the more gravitational energy it's going to have, right? And you can think about that with a ball. If a ball's sitting on the ground, It has no gravitational energy. If you're holding a ball up, it has a ton, because if you let go, it's going to fall. Right? So really that just has to do with gravity and position. All right. So now we're going to do a little figuring out what it is game. So we're going to say 1 is kinetic energy, and 2 is going to equal potential energy. So taking what we just went over, and a lot of this might be review for you. Looking at this rubber band picture, type in the chat either a 1 or 2, you think it's kinetic or potential. Good. Potential, right? Someone's pulling that rubber band back. If they let go, it's going to fly. Okay. What about this beautiful picture of a man holding a ball? It's like a clip art picture. Not the second part, but just this part of him holding the ball. Bonus points if you can tell me what kind of potential energy that is. Great, thanks, Janie Mate. Gravitational potential, right? All this has potential energy because he's holding the ball up. That's it. If he lets go, gravity will pull it down. Now, what about in this picture where the ball is in motion? Would we say that one is potential or kinetic? I see 1s, excellent. It's kinetic, right? The ball's moving. He threw it backwards and it's moving. All right, what about this guy over here? What kind of energy is he displaying? Kinetic, right? He's moving. We would probably describe that as mechanical energy, right? Because it's just movement, mechanical movement of, in this case, the bear's body. What about this picture? Kinetic or potential? Kinetic. And what kind of energy do we think that is? Thermal. Yeah, I would agree, right? It looks like some kind of heat is being released here. And the last one is a picture of a glucose molecule. What do we think? Potential or kinetic? Potential. You guys are so good. So this is potential. This is chemical energy, right? Because there's actually potential in these bonds. So when we start learning more about reactions and more, heavy chemistry kind of stuff here, what we're going to find out is breaking these bonds releases a ton of energy, right? And creating the bonds takes energy. So to build molecules takes energy. If you took biology last year or previously, you might remember the molecule ATP, right? And how ATP actually basically was this exact principle. It had stored energy, and as soon as you broke off one of those phosphates, a ton of energy was released. However, it takes energy to create ATP, right? So we're going to be looking a lot at chemical energy and how that works. Okay, so the next thing is measuring energy, right? Energy is usually described in something called a joule. That is a measurement of energy. And what a joule is equal to, we see here. It is a kilogram times a meter squared divided by a second squared. Now, this might seem strange, but really what it is a force times a distance over time, basically. We also will see something called calories, right, which we are probably kind of familiar with, right? We've heard of the term calorie. So 4.184 joules is equal to 1 calorie. And calories that you see in your food are actually kilocalories, so it's actually a calorie times 1,000. But really, calories are another measurement of energy, right? Calories are basically telling you how much energy you have to use to break down that food and how much will be left over. So we're going to come back to looking more specifically at joules, and we're going to do some more calculation kind of stuff with those later. Temperature, right? Temperature is another way that we can measure energy because it is the average kinetic energy of a substance. So when you take your temperature, you're measuring the average amount of kinetic energy inside your body, right? If we take the temperature of the air, we're measuring the average kinetic energy in the air. And we have 3 units that we use to measure temperature, right? We're probably very familiar with Fahrenheit, since that's what we hear about all the time here, right? You might also be familiar with Celsius, especially if you have family in Europe, right, where they use Celsius. So those are the 2 that we're most familiar with. And then Kelvin is technically the standard unit of temperature. Scientists created this so that you wouldn't have any negative temperature measurements, which really doesn't seem like something that's necessary, but somebody somewhere, someone probably named Kelvin, thought it was a good idea. So Kelvin is weird because the freezing point of water in Kelvin is 273.15. The boiling point of water is 373.15, right? And really, the annoying thing about Kelvin is that it has no meaning to you, right? If you say, oh, it's 200 kelvins outside, you're like, what is that? However, you might see kelvins. And notice there's no degree here. It's just kelvins, whereas Fahrenheit and Celsius are in degrees. So here's a nice little meme, GIF, kind of, not GIF, meme, essentially, of these 3 things. So when it's Fahrenheit, right, if it's 0 degrees, it's really cold. If it's 100, it's really hot. For Celsius, if it's 0, it's pretty cold, right? It's enough for freezing. If it's 100 degrees Celsius, you're dead. For Kelvin, if it's 0 degrees Kelvin, you're dead. If it's 100 degrees Kelvin, you're dead. Or no, you're not dead. Oh, no, you are. Just kidding. You're dead in every situation. My thing was getting blocked by the Zoom cameras here, right? So that's kind of a good way to like put it in perspective here that the Kelvin scale is pretty small. Like 1 Kelvin is going to make a big difference. So how can we convert between these temperatures? This can be useful if you are getting data in, for example, Celsius, and you want to put it into kelvins, or you are getting vice versa. Converting between Kelvin and Celsius is really easy. So that's the one that we're going to practice doing today. Converting between Celsius and Fahrenheit is annoying. We'll look at the formula for that, but it's annoying. So the formula to convert this really is that kelvins are going to be equal to the temperature in Celsius plus 237.15. So we're going to practice right now. First, we're going to convert Celsius into Kelvin, and then we'll convert kelvins into Celsius. So take a second here to convert both of these degrees Celsius temperatures into kelvins. Okay, so for our first one, excellent, we got 255.15 Ks, or kelvins, right? All we did was take 18 and add it to 237.15. What about for our second one? Thank you, 337.15 Ks, right? All we did was add 100 to 237.15. What about if we go the other direction? So what if we're starting with those kelvins? Now we're going to have to do some subtraction here. And we want to convert to Celsius. Okay, 312.85 degrees Celsius. We can't really make a degree sign easily, so I'm just going to write out the word degrees. Again, that's pretty high, right? 312 degrees Celsius is really, really hot. Okay, what about for our 40 kelvins? Good, we actually get a negative number, another extreme temperature here, negative 197.15 degrees Celsius. Both temperatures that I would not want to be in. Okay, so that's not too complicated here, just adding or subtracting 237.15 in order to go between Celsius and kelvins. Now, if only Fahrenheit to Celsius was as easy. So this is how you convert Fahrenheit to Celsius. You take your temperature in Fahrenheit, you subtract 32, and then you multiply by 5/9, right? Super annoying. And vice versa, if you want to find Fahrenheit, right, you're going to actually multiply by 9/5 and add 32 to Celsius. So we're not going to practice doing this because honestly, converting between these two really isn't something that we're going to be doing necessarily, like, to prove our skills. The nice thing too is that you can easily convert in Google, right? So if I want to convert, if you type like Celsius to Fahrenheit, it will give you a calculator, right? And you could type in, okay, what is 37 degrees Celsius? Oh, look, it's 98.6 Fahrenheit, right? And I personally, nothing wrong with using this. Use this rather than doing that complicated math just to find a temperature conversion, right? But that's what the formula is in case you were curious and in case you want to try. You could always practice taking today's temperature, for example, and converting it to Celsius. So that is everything that we need to know about temperature and energy, at least from this lesson, as a pretty introductory lesson. So what I want you guys to try to do now is to summarize this lesson in, I said exactly 20 words, but 20 words or less. So what would you write in your notes? We're going to spend 2 minutes right now. In fact, I'm going to put on a timer, which guess what? Google does that too. So 2 minutes right now, just thinking about and writing a summary that's 20 words or less of this lesson. Writing it on your paper. Mm-hmm. Okay. So if you didn't finish your summary, you could keep working on it because we're going to be finishing up pretty soon here. But basically the point of summarizing the lesson is really to make sure that you are getting the main points of the lesson. And then that way, when you go back and look at your notes, you can look at the summary and you can say, oh yeah, okay, this lesson was about potential and kinetic energy and measuring it in joules and measuring with temperature. So I want to just explain a little bit about how the virtual sessions are going to work in this class and this year, and also what you guys are going to be doing as your exit slip. So you're actually going to be just doing your regular Canvas assignment here, the energy and temperature quiz, which is due today, right? So a lot of times I try to line this up so that we would actually be going over a lesson in Canvas, and then you would be able to do the quiz or the assignment right after. So now you don't even really have to open the assignment, or excuse me, the lesson page. You can if you want to look through it. They have some infographics in there that might be interesting. Otherwise, you can just go straight to the quiz. So how will I know who attended? So I actually can run a report and it's going to show me who logged in to my virtual session and how long they were there. And I'm going to be marking attendance that way. And to get full credit, what I'm going to do is I'm going to stop recording the session in just a few seconds, and I'm going to tell you guys a secret password that you are going to write either in a comment on your quiz or on your quiz. And people who don't have the password, who are watching this later, they are actually going to not have points taken off, but if you have the password, I'm going to add points to your quiz. If you already finished the quiz, then you already finished it, Janie. I'll just write it down here. When I'm grading it, I will just add in some points for you. So I'm going to be giving bonus points on assignments for people who attend. Okay? So make sure you stay for the password, which I'll say in a second. But regardless, you can now do this energy and temperature quiz. If you already did it, great. You could start moving on to already working into next week. So we have a lab next week. We are going to be doing a lab on moles. So it's our first of 2 labs, and it's going to be at 10 a.m. I will be at Miwa. If you would like to come do the lab in person, you can. If you'd rather attend virtually, that's fine. I will have the virtual session set up, and either I or someone else will be doing the lab, and you're going to be participating with them. So moles are a super useful concept in chemistry, so we're going to really talk about them and how to calculate them, and we're going to practice doing that. So that's going to be our first lab. So that's going to be our virtual session next week. The week after that, we're going to be doing a check-in virtual session. So how that's going to work is I'm going to give you a problem or example, and we're going to work through it together, and then I'm going to just take questions. So as you're going through the lab or the lessons and you come across something that you're confused by, just take a note on it, and then you can ask me during the virtual session. And then if you have no questions that week, right, you're just going to come in, do the check for understanding question, and be on your way. So next week, mole lab. It's going to be exciting. Okay, otherwise, do you guys have any questions for me about the class? You could go ahead and type them in the chat. It could be about an assignment. It could be a general question. Oh, and you know what I just realized? I could type the secret word in the chat because the chat doesn't get recorded. Ha ha ha. Okay, so here's our code word. So it's in the chat. And if you put that in your quiz, except for Janie Mae, who already did the quiz, I will be adding points to your quiz. Okay. Can you pass the class if you don't attend any virtual sessions? I'm just wondering. Technically, I think you could still pass the class. If you don't do the labs, that's going to really impact the grade pretty significantly because they are a test grade. But if you got 100 on everything else, you could probably still pass. How come so little people show up if they're required? I don't know. It's something that we're working on to get 100% attendance. So, no, Janie Mae, you're good. I wrote down on my list here just that you were here, so don't worry. Yeah, so hopefully we'll be getting 100% attendance. I know some people are still finding out which classes they're in because there were some technical issues. So it could be some of that. Maybe people didn't realize that the sessions were starting this week, right? I'm not sure, but all I know is that we're doing them every week, right? So I've tried to make it useful in terms of doing lessons, labs, and office hour type situations during them. Okay, yeah, and if you're not going to be able to make a session, right, because you have some, you have an appointment or you're really stressed and overwhelmed that week and it's just something that is not going to be feasible for you, just send me an email, let me know. Okay, any other questions? Okay, well, if you have any more questions that you think of later, just feel free to email me. You can go in, email me about your mentor seminar ones. You can go in now and do your energy and temperature quiz. If you'd like to do it later, that's also fine. Make sure you include the code word if you haven't already submitted it so that I can give you some extra points. All right, and thank you guys for coming today, and I will see you next week. Oh, how do you include it? Just put it in a comment or in one of your answers is fine.